Okay, so this is the coding video for the temperature controlled fan Arduino MnRI gadget. This code is pretty complicated. It's not quite as complicated as some other gadgets we've done. There's only 280 lines here. So it's pretty complicated and it uses a bunch of different things. So I'm not expecting that you'll understand all of this. If you guys get one little thing out of this, that's great. You know, if you can just figure out how to use the temperature sensor so you can use it for a future gadget, or if you can learn the LCD a little bit better so you can change what things look like if you want to. Just little things. If you can figure out little things, that's good. So we're going to go through this. Hopefully I do an okay job of explaining this to you as we go. But I hope that you get something out of it. So as normal, when we're doing Arduino stuff, we first need to include the various libraries that we're going to be using. And in this case, we're using the LCD screen, so we need the liquid crystal library, and we're using the DHT11 temperature and humidity sensor. So we'll need the library for that, simple DHT. So we include those, which basically tells the Arduino programmer, okay, when you put my code on an Arduino, make sure that you bring in that other code too, so that I can call functions from that code, so that I can use those capabilities. Then we do what I typically do, which is I define little preprocessor variables for all of the different pins that I'm going to use. So remember, the way that this works is you say define, and then you give the name of the thing and a value for it. So basically what this does is it tells the programmer, go through the code, and everywhere I've used this name, RS, replace it with the number. So every time you see RS, replace it with 5. Every time you see E, replace it with 6. D4, replace it with 7. I like to use these for pin definitions for Arduino gadgets because it makes it really easy to change what things are plugged into right off the bat. Everything's defined up here. I don't have to go looking for it in the code. I can just say, oh, okay, for the LCD, for instance, I've got data 4 through 7 plugged into 7, 8, 9, and 10 digital pins on the Arduino. What if I want to move those? Just change them right here. Don't have to change them anywhere else. Don't have to go looking for them. It's right, nice and easy. Now, the reality is you could just put the numbers directly in. Like you can see down here, this is where I define the liquid crystal display. This is the only place these variables are used. So you could just put them in, but I like to have them in as preprocessor defines because it makes the code a little more readable. I don't just have a string of numbers here, you know, 5, 6, 7, 8, 9, 10. I have names that tell me what pin that is, which is, I think that's a beneficial thing. So we define the LCD pins. We have to define the signal pin for the DHT11, which is 4. We define the 4 input pins for the buttons, 11, 12, and 13. And we define the pins for the L239D motor controller chip. Now, this is a pretty complicated chip. But basically, what you need to know is that there's one pin that kind of enables the motor, and then one pin that sets the direction going one direction, or sets the speed going one direction, and one pin that sets the speed going the other direction. So direction A and direction B. Then we've got a variety of defines, actually just 2 defines here that aren't pins. So this one is defining, I'm actually going to comment this out because I don't need this anymore. This one right here basically says, oh, if I want to print out debug information over serial, I'll have that defined, but I don't want to, I don't need to. And this one defines the temperature mode. So basically, the code defaults to doing things in Fahrenheit, but if you want to have the temperatures displayed in Celsius, you can uncomment that. So there's an easy thing. If you want to see the temperature in Celsius instead of Fahrenheit, just come in here, remove those 2 lines. There you go. Or 2 lines, those 2 slashes there. That's uncommented it. Right. Next, we initialize the liquid crystal library. So again, we have to give it the pins for the liquid crystal, the RS, the E, the D4, 5, 6, and 7, and all of those pins, data 4 through 7, that is. And we have to initialize the DHT11 library with our signal pin. So basically, this is going to the code that we imported up here and saying, okay, we're going to be doing stuff with the liquid crystal display. Here's the pins that we're going to be talking about. We're going to be doing stuff with the DHT. Here's the pins we're going to be talking about. Okay? Oops, I accidentally delayed something there. Next, we are going to do some definitions. So these are some global variables that we're going to want everybody to be able to access. We have things like temperature in Fahrenheit and Celsius. So these variables are going to contain the current temperature in Fahrenheit and Celsius. We have fan mode. So the way the fan mode works is there's 3 modes for the fan: off, controlled by the temperature, or set manually. So we represent that as a integer variable. 0 is the first mode, 1 is the second mode, 2 is the third mode. That's computer scientist stuff. For some reason, we want to count starting at 0. So we start from 0, then 1, then 2. So those are our 3 modes. And then basically we can check, hey, what's the fan mode? It's 0. Okay, the fan should be off. It's 1. Okay, we need to make sure it's temperature controlled. Or it's 2, needs to be manual. And then we set the fan speed. Now, if I'm not mistaken, I'll confirm this when we get on a little further, but the fan speed is an integer between 0 and 255. So 0 is the lowest, 255 is the highest. So 200 is a pretty decent speed. I think that's what, like 70-ish%. So if you just go directly to manual mode, that's the speed that everything will be. The next thing is for the fan temperature controlled mode. So we specify a minimum temperature and a maximum temperature. So at the maximum temperature, the fan will be at max speed. And for us, this is 70. At the minimum temperature, the fan will not be off. For us, this is 50. So this is in Fahrenheit, not Celsius. Everything in the internal calculations is done in Fahrenheit because I'm American and I didn't grow up with Celsius, so it's not very intuitive to me. Even though it is objectively kind of a better system of measurement. I did everything in Fahrenheit because it's intuitive to me. And then we define this temperature range. So this is the amount of degrees over which we're going to vary the fan speed. Now here is something you might want to change. For me, when I was making this, in the room I was making it in, it was like 67 degrees or something. So I could get the temperature to go up to 70 by like putting my hand on the sensor with my body heat, or I could get the temperature to go down by blowing on it. But this was a good range for me. You might find that with the readings in your room or with just your sensor, you might want to define a different temperature range. But so remember, the minimum temperature, below it, the fan will not turn on. At the minimum temperature, it'll be on a tiny little bit. And then in the maximum temperature, the fan will be at max speed. Anything higher than that, it will still stay at that speed. Okay, the next part here, and this takes up almost 100 lines, it feels like. These are all the custom character definitions. So I showed this with the LCD runner. I'm going to switch my screen sharing here and show you. Where's my correct thing? Sorry, 1 second here. Yes, this custom character generator. So this is what I used for this. It's a really great way to generate custom characters for an LCD. So these dark pixels, the ones that I'm clicking, these are going to be the ones that are lit up on the LCD, because obviously it's on the LCD in my kit anyway, it's a blue background and then white pixels lit up. So these dark ones are going to be the ones that light up. So what you can do to make a custom character is you click on these, you take this custom character thing, you put it in your code, and then you do this create character function in your setup. And we'll get to that in a minute. This is a really great tool by Max Promer, I think is the name. Oh, here's another thing. Oh, nice. I didn't even, I've used this a bunch of different times. Never even noticed this. So you can use a blue mode, and then you can see what it's going to look like on the blue. That's great. Wonderful. You could also change from binary to hex. So if you're not familiar, computers count in a bunch of different ways. They don't count in the base system that's most familiar to us, which is base 10, which if you're familiar with that, you know that means you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you say, okay, 10, that's 110, and then we're going to start back from 1 again. So our number 10 is 110, 0 ones. Our number 11 is 110, 1 1, so that's 11, 110, 2 ones, and so on. We count like that. Computers don't count like that. It's not very convenient for them. Computers generally, at the base level, they count in binary, which is zeros and ones. So basically you can have 1 1, 1 2, 1 4, 116, 164, all the way up to, you know, however many. And this is because when you get down to the hardware level, representing things as a binary, as on, off, 0, 1, true, false, that kind of a thing, makes sense. Because when you talk about electricity, it's very easy to have things be powered or unpowered. So a 0 or 1 makes a lot of sense for powered or unpowered. But another representation that's very common in computer science is hexadecimal. Hexadecimal is base 16. So that means we count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we need to count up to 15. But we need to do it without using the numbers. So we actually use letters. We then do A, B, C, D, E, F, and then, okay, that's 16. So then we're going to have 116, and then we start again from 1. So for instance, 16 in hexadecimal is 10, which looks like 10 in base 10. But I've gotten off on a tangent. This is a whole other thing. So yeah, computers sometimes count in base 16, sometimes they count in base 2. That's what binary and hexadecimal mean. Let's just leave it at that. Sometimes I get a little carried away with my explanations. Okay, back to the code. All right, so we are currently looking at the custom character definitions. I defined an on-off symbol, a fan icon, an up arrow, down arrow, a degree symbol, and a percent symbol. And you can see all of these on the LCD if you've used this gadget. Now there's some functions here, but I'm going to go down all the way to the bottom here. And we're going to look at our setup and our loop functions. And remember, when we're talking about Arduino, we have two functions that are the main thing. This setup function here, which is all the code through here. This setup function is what's done first. When the Arduino turns on, it does this, and then it does the loop function. And it does the loop function over and over again forever. It runs the setup function once, does the loop function forever. So our setup function, we initialize the serial library in case we want to do some prints from it. We set up our LCD. We tell it we've got 2 lines, 16 characters per line. Then we create our custom characters. So we bind these numbers, custom character 0, to the on-off custom character we defined, custom character 1, to the fan icon, and so on. Okay? We've created these. Then we clear and home our cursor for the LCD. And then we print our LCD stuff. So the top line of the LCD doesn't change because it just displays what does button 1 do, what does button 2 do, what does button 3 do, right? So the top button or the top line of the LCD, we just do once. So we print out what the buttons do, and we show these nice little this is how we use these characters. So LCD print parentheses character parentheses 0 is going to print this on-off character. So we're printing out, okay, button 1 is for on-off. Button 2 is the fan icon up. Button 3 is the fan icon down. So that controls the fan up or down. And then the percent and degree are used elsewhere. Okay? And then we set up our buttons. So button 1, 2, and 3, set them as inputs. And then we set up our motor. So the first thing we do is we write to our enable pin to enable the motor. Then we set up the direction for the motor and enable it to run one way. Now, this motor control stuff is a little tricky, and I can't really explain all of it right now. So that's something, if you want to look for more information on, we'll have some, I'll try to have some links for you that you can look at for motor control stuff. Okay, so we set everything up. We set up our buttons, we set up the LCD screen, we set up our characters, we set up our motor. Now it's time to run the loop function. First thing we're gonna do is we're gonna run the temperature update function to check the temperature, then the button update function to get the button press states, then the fan update to change the fan speed, and then lastly, we're gonna update the UI. And if we're doing debug prints, we'll print them out right here. And if we aren't, we'll just skip it. And then we wait for 100 milliseconds and continue on to the next one. So I'm gonna close these functions up. Let's open the loop again here. Let's look at temp update first. So this is getting the temperature from the DHT11. So basically, we need to set up these two variables to read the temperature and humidity into, right? Then we need to have a variable to store error codes in. So what we do is we call this read function on the DHT11 object that we set up earlier. Remember, we set this up here, our DHT11 object. So we call the read function on it, and we pass in, hey, here's where you can put the temperature, here's where you can put the humidity, and we check to see if that error is a success. So basically, the function is going to return an error code, and that error code could mean success, or it could mean a bunch of different types of errors. So essentially, we run the function. If it didn't work, we just exit out of our temperature update function. We leave the temperature as it was before, we exit out, whatever. If we didn't read correctly, whatever. We'll just skip. We'll just skip for this loop. But if it did work, we'll move on. And first things first, temperature C, we'll just have to cast our temperature to an integer because the temperatures are read in as integers. And then temperature F, we have to actually do the Fahrenheit calculation for that. Something that's missing here is the humidity. So we don't actually do anything with the humidity. We read it in, but we don't do anything with it. So a good place to start might be trying to, how about trying to increase this serial debug print to do humidity, right? Serial print. Probably we need to cast this to a floating point number. Trying something like that. So you can get in your debug print, remember you'd have to define this back up at the top. Let's define debug so that debug statements are going to be printed out. See, now it's ungrayed out in my IDE here because it's going to be used. Try and print out the humidity, and then maybe you want to do something with that. Maybe you want to add your fan control. Maybe you want to add humidity into that equation, or maybe you just want to display it. Either way, we could do something with that. And trying to print out the reading from the sensor into serial, or into the serial monitor would be a good way to start that. Okay. Next in our loop is the button update. So the button update's pretty simple. We just check the different button values. We read them in, button 1 value, button 2 value, button 3 value, okay? So for button 1 value, we check to see if it's been released. So the button change actually happens not on press, but on release, okay? And we say, okay, if the mode is less than 2, so if it's 0 or 1, we'll just add 1 to it. If the mode is 2, we need to flip back to 0, right? Because we have 0, 1, and 2 as our valid modes. So if the button mode is 2, we'll set it to 0. If it's less than 2, we'll just add 1 to it. So we'll kind of cycle through those. And then for the button 2 and button 3 values, if they've been released, we're going to change the fan speed. So for button 2 is increasing the fan speed, right? So if the fan speed is less than 255, we add 10 to it. And button 3 is for reducing it. So if it's greater than 5, we subtract 10 from it, okay? So this ensures that we kind of move up and down in a straightforward way, and that we never have a negative buttons or fan speed, or we never have a fan speed greater than 255. Now, one thing I'll say is currently this allows you to change the fan speed even if the fan's off, even if we're in the fan off mode. So another thing that you could do here is try to add an if statement checking what the fan mode currently is. So if fan mode equals, and then what would you put here to decide whether or not you want to check these button states. Because we don't really care how you change the button or the fan speed when we're not in the manually controlled mode, right? Because when we're not in the manually controlled mode, it's either off or it's controlled by the temperature. So maybe you want to add this, but what are you going to put in here? That's the real question. What is the one mode that we care about this in? It's manual mode. What's the number for that? Okay, I'm going to revert all those changes. Let's quickly get back to that. Okay. So we've read in our buttons, we've updated either our fan mode or our fan speed. Now it is time to do the fan update. Now this is where we actually get to change the fan speed. CUI update, here we go. So if the fan speed is 0, we're gonna turn off the fan. Or sorry, fan mode is 0. We're gonna turn off the fan, okay? So we write to the enable pin, we write low voltage, okay? And then if the fan mode is 1, remember that's temperature controlled, we're going to first check to see if the temperature is less than the minimum temp. If it's less than the minimum temp, we're gonna also turn it off, okay? But if it's not less than the minimum temp, we should see what we can do. So what we're going to do here is we're going to create this number, fan control percent, that's going to be a percentage of how high the fan should be on. Okay? So fan control percent, and we define this as the difference between the temperature, current temperature, and the minimum temperature as the percentage of the range. So if, for instance, we are 2 degrees over the minimum temperature, let's say it's 50 degrees is the minimum temperature, we're set at 52, we're 2 degrees over, the temperature range is 20 degrees, we're 10% of that 20 degrees. If we're 10 degrees over, we're 50%. Okay? That's how we get that number. But it's going to come in as a floating point number. So it's actually going to come in as point. For 50%, it'd be 0.5. For 25%, it's 0.25. For 10%, it's 0.1. Okay? And we add this little safety check here that if we get a number that's larger than 1, which is 100%, we just set it to 100%. We can't go higher than 100%. Right? Okay. And now we define our fan speed as basically we multiply our fan speed percent times 255. So if we're at 100%, 1 times 255 is 255. If we are at 50% or 0.5, 0.5 times 255 is whatever 255 type, whatever half of 255 is, which is 127. Yeah, 127.5 technically. Okay, and then we write to the enable pin the fan speed. Okay, now this is the critical part that I didn't explain very well earlier. The direction pins here enable directionality on one side or the other. You can go one direction or the other. When we enabled that, or when we ran this stuff in our setup, we were saying we can go direction A, we can't go direction B. But we'll write something to the enable to kind of just prime the motor, basically. The enable is where we write a number, we write basically a voltage of a certain amount. So no voltage, the fan's going to be off. Full voltage, or 255, the fan's going to be at full speed. Anywhere in between there, and it's going to kind of be, you know, whatever the percentage that is. So when we look at this code here, we notice these are digital writes. A digital write can only write low or high. It's binary, 0, 1, low, high. Here we do an analog write, which means we're actually going to write kind of more of a percentage of voltage in this case. So we use the fan speed for that. And then the last part of this is really easy. If we're in fan mode 2, we're just going to write the fan speed. We don't need to calculate it because it's not based on the temperature. We'll just write it out to the enable pin. And if we're not in fan mode 0, 1, or 2, we're just going to return because I don't know what to do about that. Right? Okay. Lastly, in our loop function, so we've looked at temp update, button update, fan update. Now it's time to look at the UI update. This is really simple. You just need to write the bottom line. So the bottom line needs to write out the temperature. So first we have this if not defined, if ndef. If not defined Celsius, we're going to print out the temperature in terms of Fahrenheit. So it's the temperature in terms of Fahrenheit, our degree symbol, and then F. If it is defined, we're going to print out the temperature in Celsius, our degree symbol, and then C. Then we're going to calculate our fan speed percentage, which honestly, we calculate that here in the fan update. So like we could just bring that over into here somehow, but I prefer doing this here because here, instead of doing the float where it's between 0.0 and 1.0, it's 0 and 1 for 0 and 100%. So it's more human readable, but not the way we wanted to do it for the computer. Yeah, so first we've generated the percentage. Then we're going to say, okay, fan, if our mode is 0, it's off. If our mode is 1, we're going to print T to indicate that it's temperature controlled. And then we're going to print the percentage. And I decided if the percentage was less than 10, I'll just print 0. Because at 10% speed, the fan doesn't move anyway. The voltage is so low. So, you know, just print out the 0. It's fine. And in mode 2, we'll do the same thing. We're just going to omit the T. Okay, that is everything. That's how this code works. So we set up everything here at the top. We set up our liquid crystal and simple DHT stuff, our global variables, our custom character definitions. We do our setup with characters and LCD things, our button lines, our motor. Then we do our loop. In our loop, we first get our temperature. If we fail to actually read something, we just return. We give up and do it next loop. Then we get our button states and change our mode and our fan speed based on them. Then we change our motor speed based on the fan mode and the fan speed. And then we print out stuff to our LCD to do the UI. Okay, so that is everything. I really hope that you've learned something. Try to play around with the humidity on the DHT sensor. Play around with changing the minimum and maximum temperature. Maybe if you want to do the calculations in Celsius instead of in Fahrenheit, maybe that would be a better way of running things. That's pretty much everything. I do want to include a final warning to just remember, if you build this gadget, make sure you use the power supply on the breadboard. Do not try to run the motor directly off of your Arduino. Okay? Now, I personally have never tried that, and so I've never had an issue with it. I know of people who have tried it running the Arduino off the board directly instead of off of an external power supply, and it has burned their boards out. So do not run it off of your Arduino's power supply. Use that external breadboard power supply module, okay? Make sure you use that. Be safe, be smart. I really hope you enjoy building this gadget. And as always, stay curious, keep building things, keep taking things apart to see how they're made, with permission, of course. And I'll see you soon.